Solve the following equation. An equation in which the variable occurs within a radical is called a radical equation. To solve a radical equation involving a square root, first isolate the term with the radical on one side of the equation. Then square both sides of the equation since the radical is a square root. The process of squaring a square root will remove the radical. This will result in a polynomial equation. We then have to solve that polynomial equation, which in this course will be either linear or quadratic. Make sure that you check your answers and reject any extraneous solutions. For a radical equation, we can get extraneous solutions as a result of squaring both sides. Note that when we square both sides, we also will get the solutions corresponding to one of the sides being opposite in sign. As an example, consider this equation. Square root of 5x equals 3x plus 2. If you square both sides of this equation, you get the exact same result for the equation negative root 5x equals 3x plus 2, because the process of squaring a negative will result in a positive. For this example, the square root of 3x minus 4 minus 5 equals 2. We first must isolate the radical. To do that, we'll add 5 to both sides of the equation. We then have the square root of 3x minus 4 equals 7. Now that the radical is isolated, we can square both sides. This results in 3x minus 4. Notice we have completely removed the radical, equals 49. We now have a linear equation. We must solve for x by isolating it. We'll first add 4 to both sides. This results in 3x equals 53, and then we divide both sides by 3 to solve for x. This gives us our result of x equals 53 over 3. We'll check our answer by simply plugging in 53 over 3 into the original radical equation. The left side is equal to the square root of 3 times 53 over 3 minus 4 minus 5. This gives us the square root of 53 minus 4 minus 5, which is the square root of 49 minus 5, or 7 minus 5, which is equal to 2. Note that this then is equal to the right side of the equation. Therefore, 53 over 3 is a good solution.